I'm going to do question number 4 in several parts. Question number 4 on your handout has, oh my goodness, how many parts to it? We've got parts A through G. So I'm going to split this question up for you. What I'd like to do first is have you come with me to my paper. This is question number 4. We're going to start with part A. We're asked to solve the equation x to the third equals 25x. If an equation has degree 3, a very quick rule of thumb, and again, as courses get more advanced, you'll learn more rules. But in general, if an equation has degree 3, the maximum number of answers that you're going to see for that equation is 3. Let's go ahead and solve this by using the zero factor property. So we're going to start off by setting one side equal to 0. Descending power order equals 0 is called standard form. When I factor this, I start out by taking out my x, which leaves me with x squared minus 25. And of course, factoring, you should always factor completely. This x, and then this breaks up or factors as x plus 5 times x minus 5. Now, to finish this equation, we're going to set up 3 cases. If 3 numbers are or 3 factors are multiplied together to give me 0, then what that means is either the first factor is 0, or the second factor is 0, or the third factor is 0. If x is 0, there's one answer. If x plus 5 is 0, that means that x is equal to negative 5. There's another answer. If x minus 5 is 0, that means that x is equal to a positive 5. So this equation of degree 3, which is also called a cubic, does have 3 distinct real answers. The solution set would be the set with 0, negative 5, as well as positive 5. And we solve that by using the zero factor property. Now, when I look at example B, or actually equation B, x to the third minus 2x squared equals 9x minus 18 is also a cubic equation, degree 3, so we could be expecting as many as 3 solutions. Let's put this in standard form. X cubed minus 2x squared minus 9x plus 18 is equal to 0. Standard form for a higher order equation, meaning an equation whose degree is higher than 1, descending power order equals 0. Now this is where you need to pull from your bag of tricks with factoring. When you see an expression with 4 terms in it, in general, factoring by grouping is required. We always look for the GCF to start with, but the only GCF here is a 1. So it's not real helpful. If I factor by grouping, look what happens. If I group the first 2 together, I pull out or factor out an x squared. In parens, I would have an x minus 2. In the next grouping of 2's, I would factor out a negative 9, and in parens, that would leave me with an x minus 2. And understand that to finish this, I have one term here and I have another term here. These 2 terms have x minus 2 as their GCF. We pull out the x minus 2, and then we're left over with an x squared minus 9. And of course, let's factor until we can't do anything else. We have and that's called factoring completely. We have an x minus 2. The x squared minus 9 becomes x plus 3 times x minus 3. And now what we're going to do is set up our 3 cases to solve this equation. If 3 factors are multiplied together to give me 0, then when I come over here and I set up my cases to actually solve the equation, either the first factor is 0, or the next factor is 0, or the final factor is 0. In this first case, x is 2. There's one answer. In the next case, x is negative 3. There's another solution. And in the final case, x is positive 3. So our solution set here, let me come on down, our solution set here would have 2. And sometimes you can abbreviate this, putting a plus or minus in front of the 3 means a positive 3 as well as a negative 3. And we're done. Our final equation here is also degree 3. Notice it's already, this is part C. Notice it's already in descending power order. I'm going to start by factoring out the GCF, which is a y. In parens, that would leave me with y squared minus 10y plus 9. This, of course, equals 0. As I continue, this becomes y minus 9 and y minus 1. It's a good time for you to use your factoring skills. We're solving equations by factoring. I have 3 factors multiplied together to give me 0. So either the first factor is 0, or the second factor is 0, or the third factor is 0. In the first case, y is 0. In the second case, y is a positive 9. And in the third case, y is a positive 1. My solution set here would contain 0, 9, and 1. All right, so we're basically using our factoring knowledge to solve these what are called sometimes higher order equations. Enjoy!